I'm Anil Kumar sharing with you a question from my subscriber. It is basically many questions in one regarding ambiguous cases. I've combined all of them in one video. So this video is going to be long. So if you have patience for 15 to 20 minutes, watch it, otherwise not. The question here is, determine whether it is possible to draw a triangle given each set of information. Sketch all possible triangles where appropriate. Label all side lengths to the nearest tenth of a centimeter and all angles to the nearest degree. So the very first one which we are given side C equals to 22.2 centimeters, angle A as 75 degrees, angle B equals to 43 degrees. Now my student's question is, how do we check if it is falling under ambiguous case or not? So let me answer that part first. Now, ambiguous cases are the cases, let me write down here, cases where we are given one angle and two sides. Is it okay? Since here we are given two angles and a side, it does not fall under this category. So let's understand that part. So in this particular case, it is not an ambiguous case. I hope that point is clear, right? So that explains that this is not an ambiguous case. So therefore we say not ambiguous. Right? No books will tell you that, but they do tell you that ambiguous cases are the ones in which we are given an acute angle normally and two sides. We also consider when it's an obtuse angle and you cannot form a triangle. Okay, in any case, let's move on now. So side C is given to us and two angles. Let's sketch a triangle, correct? So let's just make a triangle. It doesn't really matter where we write what. But if we write kind of 75, that seems to be the big angle. So let me write this angle as 75 degrees, right? So, and then we have 43, that seems to be more than that. Let me write 43 degrees here. Angle A, so A comes for 75, B for 43, C the other vertex, and opposite to C is 22.2, right? Now in this particular triangle, you can always find angle C, right? So what is angle C for you? So that should be your first step. We're trying to just solve now a simple question based on Sine Law rather than looking into ambiguous cases. So we say angle C is equals to 180 degrees, take away 43 degrees, and then take away 75 degrees also. Since sum of the three angles is 180 degrees. So 180 minus 43 minus 75 equals to 62 degrees. So we get C as 62 degrees. Now it is simple application of Sine Law to find the sides. How do we find the sides? Let us say, let me call these sides as A and B, right? So this side will be A and this side will be B, opposite to B. So I can write, since I have to find, let us say, side A, then I'll write A over the angle opposite, sine 75. So this is Sine Law, is equal to what is given to us, side 22.2 divided by sine C. So A is equals to sine 75 over sine C is 62, right? 62 degrees, we just calculated, times 22.2. So we can calculate A using the calculator. So let's do this first multiplication. So I prefer to write numbers first. 22.2 times sine 75 equal to, right? And then we will divide by sine 62. So if you do like this, you may not get errors. 24.28. Else sometimes you may get wrong answers or errors. It also says we have to do it to nearest tenth, so we'll round it to 24.3. Does it make sense? So that is how you're going to solve the triangle. Okay, so we have found one side. Let us now find the other side which is b for us. So we'll use the same formula, b over sine 43 equals to, use the data which is given to you, right? Since the other calculated information may lead to approximate answers. So we can now write b equals to, so I prefer to write 22.2 first, multiply by sine 43 and then divide by sine 62. So notice this time I have written in the way I want to perform the operation. So 22.2 times sine 43 equals to, divided by sine 62 equals to. So that gives me 17.14, rounding it to 17.1. Now second part to this is units. So when you write answers, write your units. Say A equals to 24.3 centimeters and B equals to 17.1 centimeters. So B is 17.1 centimeter and A is 24.3 centimeter. Centimeter. Sorry for that. Okay. So I hope all this concept is absolutely clear. Now let's move on to the other examples on ambiguous case. This time we have to solve a triangle where A is 7.3, B is 14.6 and angle A is given to us as 30 degrees. So let me sketch the triangle first. Okay, so we have this angle A here. So we are saying that the angle A is 30 degrees. That's the angle A, and this angle A is 30 degrees. We are given two sides. One of them is opposite to A. Okay, so we really don't know how the side will be. So just like that, I am drawing a dotted line, which helps me to, solve the questions, and then finally we'll sketch. So if this is capital A, the vertex, opposite side is 7.3 centimeters. Side B is given to us 14.6. Whatever is the second side given, right here, 14.6 centimeters, and the vertex will be B, opposite to it. Now since we have a situation where we know that A is less than 14.6, correct? So we could try for ambiguous case. That is the whole idea. First thing is, it should be less than that. So let's find the height of the triangle now, right? Let's find the height, h. So height h, you could find using that side, 14.6, and sine of angle, sine 30 degrees, correct? So let's do this. So we'll do 14.6 times sine 30 degrees, which gives us in decimals 7.3. Perfect. So this is equal to 7.3. Now this is 7.3 for us. Now clearly these two are equal. So we say that A is equal to 7.3, which is the altitude, right? And therefore only one triangle is possible. Is it okay? So that is a special case when only one triangle is possible, and that is a right angle triangle. And now we are sure that actually speaking, the solution for us is this. Let me re-sketch the solution now. Does it make sense to you, right? So I hope the concept is clear, right? So let's see here, and this is 30 degrees, that is 14.6. The side is already given to us as 7.3, and what we figure out is that this is a right triangle. Now since it is a right triangle, we can find other things even without doing many calculations. 90 minus 30, right, will be 60 degrees. That is 90 degrees minus 30 degrees equals to 60 degrees. Okay, and that side will say AB is equals to square root of smaller than 14.6, of course, minus 7.3 square, and let's calculate this value using the calculator, right? So we have square root 14.6 minus, 14.6 square minus 7.3 square, right? And that is equal to, let's write decimal value, 12.64. So it is 12.64 0.64. Let's round it to one decimal place, 12.6. So this becomes 12.6. And now we know our triangle in details, correct? So it's a right angle triangle. So let's take another example now on the ambiguous case. So this is the third example for us. We need to solve the triangle where two sides and an angle is given to us. That means it could be ambiguous case, right? So let's sketch our triangle. So as I said, make the angle A on the left hand corner. So this becomes our angle A, which is 33 degrees. Is it okay? Now, one side is given to us as 2.8. So 2.8 I'll always take along this side above this angle 33 degrees, and I'll write this as 2.8 centimeters. And since this is B, the vertex here is going to be B, right? So opposite to B, we have B. We are given 1.3 centimeters, which is kind of small, but what I will do is I'll just connect this. We don't know what exactly, where will it land, right? We really don't know, but we know this is 1.3 centimeter long. To find what kind of ambiguous case we have, we'll find the height h. So height h in this condition will be equal to 2.8 sine of 33 degrees, correct? And that is equal to how much? Let's use the calculator. 2.8 times sine of 33 degrees is equal to 1.524. Now, since we know that side A, which is 1.3, is actually less than 1.524, therefore a triangle cannot be formed, right? So we cannot have a triangle. It's only 1.3. This side, this length is 1.5. So that is kind of short. Do you see that? Lesser than 1.5. So we cannot make a triangle. So in this case, we cannot make a triangle. So that is not possible, right? So that is an ambiguous case. So whenever we are given two sides and an acute angle, you should try for ambiguous cases by calculating the height or the altitude of the given triangle, right? Let's move on to another example. Now in this example, we are given the values of two sides A and B and an angle A, right? Okay. So let's sketch the triangle first. So I'm just making an approximate diagram with angle 35 as for vertex A, right? Okay. The side A is 7.2. So let us assume, so I'm just assuming, right? So this green line for me is to start with, correct? So I'm just writing 7.2 centimeters. We'll test for ambiguous case since we are given an acute angle, right? So we have an acute angle and two sides. So we are going to check for ambiguous case. Side opposite to A is A, which is 7.2, and then we have 9.3 centimeters here, and that is against vertex B. So we'll call this as vertex C. The idea is to find the height or the altitude of the triangle. Now in this particular case, what is height equals to? So we say height is 9.3 sine of 35 degrees. So let's use calculator and figure it out. 9.3 times sine of 35 degrees is equal to 5.33. Now clearly we know that 7.2 is, so now what we get here is this height is 5.3, for example, correct? Now here what you see is that 7.2 is actually greater than 5.3 and is less than 9.3, correct? And therefore we have two possible triangles, and that's what we mean, right? So what we'll do is now we are going to solve this thinking we have to first calculate angle B, and then we know clearly that we do have another triangle like this where these two sides will be equal, right? So that we'll call as B dash. So these are the two solutions we have to work for, correct? Now let's apply the sine law to find the angle B, right? So we say sine of angle B is equal to, divided by the side opposite, which is 9.3, is equal to sine of 35 degrees over 7.2, or sine of B is equal to 9.3 times sine 35 degrees divided by 7.2, correct? So let's calculate this. We can do 9.3 divided by 7.2 equals to multiply by sine 35 equals to. So we'll get something in decimals, 0.74086, right? So what is angle B equals to? Angle B is sine inverse of all this. Okay, so we will shift sine inverse of our answer, right? Of our answer, and that is equal to 47.80, right? So this is 47.8. So what we got here is 47.8 degrees for angle B, right? Now, if I take a point B dash, then what is the other angle? What I'm trying to figure out now is what is for the other triangle, what is this angle? This angle will be what? 180 minus 47.8, right? So it'll be 180 minus 47.8. Okay, let's calculate this also. So it is 180 minus 47.8 equals to, in decimals, 132.2, right? So that is equals to 132.2 degrees. I'm still writing these in decimal places since I have to find the sides. It is important to understand, right? Later, what am I going to do? I'm going to round it. So I'm going to write this as 48 degrees, correct? And this will be rounded to 132 degrees in my answer. Is that clear to you? Correct? Okay, so we got angle B, which is 47.8. So we can find this big angle C. So we can say now that angle C is equals to 180 minus 35 minus 47.8, which is equal to, let's calculate, 180 minus 35 minus 47.8, which is in decimals 97.2. 97.2, which will approximate to 97. Is it okay? 97 degrees. Since the question says that we have to side lengths to the nearest tenths of centimeters and all angles to nearest degree. Perfect. Okay, so we got angle C. Now let's find what AB is, right? So we can apply the sine law to find AB. So we have AB over sine of sine C, which is 97.2. So the idea is to use at least some accuracy. This gives you more accurate result, right? And what we are given to is 7.2 divided by sine 35. So we have AB equals to 7.2 times sine 97.2 divided by sine 35, all are degrees, right? So we can just put this degree motion. So we'll do that 7.2 times sine of 97.2 equal to divided by sine of 35 degrees, which is equal to, it gives us 12.45, right? 45. So I'll round this to 12.5. which is 0.5 centimeters in our answer, right? So this particular length here from A to B, that much, right, is from here to here is equal to 12.5. So we have to round this to 1 decimal place. That's perfect. In centimeters, right? So we solved the bigger triangle. Now the question is to get the smaller triangle ACB dash, correct? Now angle C dash, this becomes angle C dash. So what we are going to do now is solve this triangle, which is, I'm just squeezing it in, okay? Kind of this one. Is it okay? Where the triangle sides are C and this is my B dash. We know this is 35 and this one is 132. I'm writing 132 now. So that will be how much? C will be 180 minus 132 minus 35 equals to 13 degrees. So this is 13 degrees. And the sides are 9.3. This side is 7.2 is given to us. That is the side, correct? So we'll sign AB. So what is AB dash? AB dash. Do you see this is a second triangle? So let me write down case 2. Okay. So AB dash over the angle, which is sine of, we calculate that to be 13 degrees. So I'll approximate. We'll just write 13 degrees. Okay. So I'm not using 1 decimal value. Remember that. Okay. Now, and what we know here is this combination, which is, or we can use 35 and 7.2 also, that's better. So side is 7.2 and this angle is sine 35. And therefore, AB dash is equals to 7.2 times sine 13 degrees divided by sine of 35 degrees. Let's calculate. So let me push this a bit so that's clear to you. And AB dash will be 7.2 times sine 13. Now this one is not so accurate, right? Divided by sine 35 is equal to 2.8. Rounded to 1 decimal place. Perfect. So we get this as 2.8 centimeters. So that is how you could have two triangles, and this is an ambiguous case since the side given to us could give us two possible triangles and its length was more than the altitude of the triangle. Second, its length was lesser than 9.3, right? So we know 7.2 is greater than the height. However, it is less than 9.3, and that gives you two solutions. Very important. At times we miss this part, and it's very important to check it out. I hope you find this important and useful to understand cases where we're talking about ambiguous cases. I'll provide you a link where we'll see what happens when we have an obtuse angle rather than acute angle and how to solve those questions. Feel free to write down your comments, share your views, and if you like, that would be great. Thanks and all the best.